Good evening. My name is Taylor Pratt, and today I'll be talking to you about the chosen molecule D-glucose. The molecule is of personal interest to me as it is present in my favourite lolly, the jelly bean. It is found in high amounts in jelly beans and can also be found in many fruits, including apricots, prunes, and sultanas, all of which are found readily in my day-to-day life. The molecule itself is a monosaccharide, or a simple sugar, and is the most important carbohydrate in biology. In humans, our cells use glucose as a source of energy or as a metabolic intermediate, which also prevents proteins from being used as energy. It is absorbed directly into the bloodstream during the primary digestion phase and is created by the body through the process of gluconeogenesis, where amino and fatty acids are used within the liver to create glucose. The glucose molecule is made up of 6 carbon, 12 hydrogen, and 6 oxygen molecules, giving it a chemical formula of C6H12O6, whose 5 hydroxyl groups are arranged in a specific way along its carbon-6 backbone. These hydroxyl groups are polar, which allows glucose to be readily dissolved in water and consequently able to travel throughout the human body. The molecular weight of D-glucose is 180.16 grams per mole, with a density of 1.5 grams per centimeter cubed, and has a boiling point of 146 degrees Celsius, becoming soluble in only water and acetic acid. In its open form, the glucose molecule has an open and unbranched backbone of 6 carbon atoms, C1 through to C6, where C1 is part of an aldehyde group, and each of the 5 other carbons bear 1 hydroxyl group. The remaining bonds of the backbone carbons are satisfied by hydrogen atoms, making glucose either a hexose, aldose, or aldohexose. Each of the 4 remaining carbons, C2 through to C5, is a stereocenter, meaning that it is 4 bonds connected to 4 different substitutions. In glucose, these 4 parts must be in a specific 3-dimensional arrangement. This arrangement can be seen in the Fischer projection on the current slide. The ring structure of glucose comes in 2 forms, either alpha or beta, where the only differences is in the positioning of the hydrogen and hydroxyl groups attached to C5. While the 2 forms look similar, the human body cannot process beta glucose, meaning alpha glucose is the only readily available glucose molecule during digestion. Without a ready supply of alpha glucose, the blood glucose levels within the human body diminish, resulting in the condition hypoglycemia, a condition which leaves the body feeling weak or tired, and can result in a seizure. That is all I have time for today. Thank you very much for listening.